At many work sites, grapples do all the heavy lifting. Dangling from crane booms, these huge mechanized claws move mountains of material one load at a time. Some are equipped with powerful electromagnets for gathering small bits of metal along with the large ones. Not much can escape the grasp of the mighty grapple. A magnet at the center pulls metal from the scrap heap, while 4 fingers dig into the pile. It then transfers the load of steel for recycling. It actually takes some of that recycled steel to make a grapple in the form of steel plate. A computer-guided flame burns through the steel to cut out the various part shapes. It will take approximately 50 pieces in a range of shapes and thicknesses to make one grapple. A press brake repeatedly rams one of the parts while an operator adjusts it forward between thrusts. The process curls the part to give it a claw-like profile. It's the basic shape of a grapple finger. Using a template, he checks the curvature to confirm it's on target. He'll curl 4 fingers per grapple. Meanwhile, a welder pieces together the grapple's core, working within a special fixture that allows him to assemble it precisely. After he tack welds them together, it's over to the robot. It does the permanent welds as the core slowly rotates in a special device. They hoist the welded grapple core over to the magnet and feed its main wire up through the core. They lower the core and it fits onto metal dowels protruding from the magnet. This allows them to align the two precisely. They thread high-strength bolts into the dowels to secure the assembly. Next, they place a turntable bearing on the grapple's top flange. This bearing is an important part of the claw rotator mechanism. They fasten the bearing's outer ring to the flange with numerous bolts, torquing each one tightly to withstand the spinning action of the bearing's inner ring. As demonstrated here, the bearing turns in both directions to give the grapple's claw movements a lot of flexibility. A worker now lowers the upper rotator assembly onto the turntable bearing. This assembly holds the rotator's motor and the manifold that feeds hydraulic fluid to the cylinders that power the claw. They now slide the hydraulic cylinders into their slots and lock them in place with pivot pins. They install a total of 4 cylinders. Each one will power 1 grapple finger, and together they'll open and close the grapple claw. They connect the hydraulic feed lines to the cylinders and reinforce the connection with a 4-bolt flange that can handle the pressure of the hydraulic fluid. They guide each steel finger into slots in the grapple core and align them correctly. They slide a pivot pin into the attachment holes to link the two. This pin will also act as a kind of hinge as the finger opens and closes. They fasten the pivot pin to the grapple with a nut that's split in one spot. This split enables it to be squeezed tightly around the large pin with a small bolt. They attach the hydraulic cylinders to the claw fingers with more large steel pins. And they're now ready to power the grapple claw and test the gripping action. The 4 tines, or fingers, open and close in unison. The tips mate correctly. There's no overlap. They roll paint onto the company emblem, and this grapple claw is now ready for the job site. It weighs 4.5 tons, and just dropping it on a car will crumple it like a piece of tissue paper. It takes about 150 hours to manufacture a grapple claw that can get a grip on the really big jobs in a matter of seconds. Whether it's boysenberry in your muffin, hazelnut in your coffee, blue cheese in your salad dressing, or spearmint in your chewing gum, the source is usually a prepared flavoring. Food and drink makers typically approach a flavorings company to custom design and produce whatever flavor they need. Not only do flavoring companies produce ingredients for commercial use, they also manufacture standalone flavoring products for retail sale, such as those syrups you squirt into coffee, fountain drinks, and other beverages. In the company's research and development laboratory, flavor chemists create each recipe, drawing from an elaborate arsenal of ingredients. If they're designing an orange flavoring, for example, they might combine orange essence and orange peel with extracts from other citrus fruits, tweaking the proportions until they achieve exactly the taste they're after. This chemist is designing flavoring for a soft drink. He pours a specific amount of his trial recipe into water, then carbonates the mix by adding pressurized carbon dioxide. Then he bottles the drink and sends it to the client for approval. Once the client gives the okay, plant technicians mix a production formula, following very precise weights and measures set out in the recipe. Once they combine the formula's key ingredients, they add them to the liquid fillers such as fruit juice and water, and solvents such as ethanol. The solvents trigger molecular changes that transform the oil-soluble key ingredients into a water-soluble state. Without this conversion, the finished flavoring would simply float on top of any liquid to which it's added. At several points throughout the process, the company's quality control lab performs an array of tests to assess color, flavor, viscosity, and other characteristics. The last ingredients to go into the production formula when the recipe calls for them are colorings. Sometimes a client wants a powdered flavoring rather than a liquid one. So chemists develop a liquid recipe that a machine called a spray dryer can process into a powder. In the production plant, workers pour the required quantity of production formula into a large processing kettle. They add whatever additional ingredients the recipe may call for, and if required, heat the mix. If they're making a powdered flavoring, then from the kettle, they pour the liquid into a mixer containing water, gums, and starches. These keep all the ingredients evenly blended. Then they open a hatch and drop the mix directly into the spray dryer. The machine uses high pressure to transform the liquid into a fine mist, then heat to dry the mist particles into powder particles. They put the powder into a machine called a ribbon blender and add whatever dry ingredients the flavoring recipe calls for. Then mixing blades slowly blend all the powders together. The plant sends a sample from the blender to the quality control lab. Among other tests, lab technicians put the sample under a microscope to analyze the particle size, which indicates how thoroughly the ingredients are blended. Exiting the ribbon blender, the finished flavorings passes through a vibrating screen, a magnet, and a metal detector. The packaging equipment weighs a specific quantity and dispenses it into cartons lined with polyethylene. A suction hose vacuums what dusts up in the process because airborne powder is an explosion hazard. The plant sends a sample from every batch it produces back to the lab. Trained testers smell and taste the sample and compare it to the model lab batch. The testers flag any production sample that's even the slightest bit off the mark, in which case they alert the flavor chemists, who then diagnose and fix the problem. This procedure, along with the various quality control measures throughout the production process, ensures taste consistency, which is absolutely critical. Whether the prepared flavoring is an ingredient in a commercially produced food or beverage, or a retail flavoring that you squirt into or sprinkle onto a drink or snack. For centuries, dog-driven sleds were a lifeline across the frozen north, delivering medicine and other supplies to far-flung communities. Today, aircraft and snowmobiles have mostly taken over that work, and dog sledding has become a sport. And a well-made sled is behind every winning team. A dog sled race is an endurance test for the dogs, the driver, and the sled itself. A good sled is both flexible and sturdy enough to go the distance. At this factory, they make sleds from white ash. A worker angles the ends of vertical bars so they can be fitted to the sled's top rail and handlebar. These bars are called stanchions. He shapes the other end of them so they'll fit into grooves in the sled's runner. All the parts of this sled are designed to fit together like pieces of a jigsaw puzzle. A worker now screws aluminum rails onto the bottom of the two runners. He slides plastic strips into those aluminum rails, which gives the runners a smooth base for gliding over ice or snow. He secures the plastic strips at each end with screws. The crew is now ready to assemble all the pieces of the dog sled. They attach metal screw eyes to the runners. They'll thread rope through them when they're ready to tie the parts of the sled together. All the parts of the framework fit into notches made specifically for them. The location of those notches has been precisely mapped out. If one is even a fraction of an inch off, the sled would collapse like a house of cards. They measure the space between the runners to confirm they're perfectly aligned, and now tie the joints together with nylon rope. These ties are called lashings, and there are 22 of them on this dog sled. Historically, lashings were made of moose hide, but nylon is tougher. They cut the rope with a hot blade, which seals the fibers so they won't unravel. They tie the midpoint joints together, and the focus then moves to the dog sled handlebar. A worker glues strips of ash together. The strips are thin so they can be easily bent, allowing him to curl the glued layer around a U-form. He clamps the wood to the form, and the glue cures for 3 hours. It hardens into the U-shape, creating the dog sled handlebar. He secures the handlebar to the dog sled with the nylon lashings. The team then assembles the bed of the sled. They clamp the slats into place and then screw them to the framework. They install the sled's front bumper called the brush brow. Next, a worker cuts off the metal bead of a bicycle tire and discards it. He uses the remaining tire tread to create foot pads by wrapping it around pieces of thick plastic and screwing it into place. He installs a treaded pad on each runner to keep the driver's feet from slipping off. Then they install an aluminum bar brake. These pivot bolts will allow this bar brake to be raised when not needed and lowered to engage the metal talons. He loops a bungee cord on each side of a crossbar and burns off an end. He hooks the other end of the cord to the brake. This simple bungee cord mechanism will enable the dog sled musher to activate the brake. He heat shrinks rubber tubing around the base of the cord to protect it. They now weave the back of the sled using nylon cord to create a basket for carrying things. It's big enough to hold a tired animal. The worker then loops and ties the bridle to front stanchions beneath the sled. He forms a V as he threads it from the back of the sled to the front. He paints urethane onto the wood and even over the lashings. This will protect them against wear. It's taken about 3 days to make this traditional basket dog sled. And now it's ready to mush. Athletic footwear dates back to ancient times, but the concept gained traction with the development of treaded rubber soles in the early part of the 20th century. These rubber-soled shoes were lightweight, comfortable, and hit the ground quietly, earning them the name sneakers. Design improvements have broadened the appeal of athletic shoes. People wear them everywhere. The athletic shoe has definitely gone Main Street. Using a hydraulic press, this employee forces a die through synthetic fabric to cut out patterns for the upper part of the shoe. At the next station, he punches out leather toe tips. The toe tip is one of numerous cutouts that add shape and structure to the synthetic upper. After arranging the tip parts on a non-stick tray, this worker places strips of thermal resin onto them. She drapes a non-stick sheet over the tray, then slides it into a hot metal press. The resin melts into the leather to stiffen and strengthen it. Another worker stamps the model number onto the heel cutout. Then it's over to the sewing department, where a worker stitches a reflector onto the athletic shoe upper. Other accent pieces call for more intricate stitching, so she arranges the parts on a computerized platform. The platform moves back and forth, allowing the needle to do a perfect job of stitching the accent pieces to the upper. This stitching would be difficult to execute manually. Once some of the more substantial pieces have been applied to the shoe, it's time to sew on a reflective logo, and the needle is once again guided by computer software. This athletic shoe upper is now ready for its resin-fortified leather toe tip. She stitches it in place, and then pieces together the collar, and sews it to the back of the shoe. She installs thick foam padding on the inside of the collar, and then turns it right side out to tuck the padding neatly inside and hide the seam. Putting on the collar has obscured the top lace holes, so she clears them with a compressed air punch. Down the line, more computerized needles embroider brand information onto the tongue panels. The next worker sews a liner and padding to the panel, again working inside out to hide the seam. Another worker then stitches a fabric base onto the athletic shoe. She applies a rigid plastic to the heel. That adds structure and support to the back part of the shoe. Further down the production line, a worker tugs the shoe onto a foot form called a last. They heat it to make it malleable enough for this machine to pull it to the shape of the last. At the same time, nozzles apply cement to glue the overlap to the fabric base. Then a machine heats both the upper and a rubber sole. The heat activates glue applied to the sole earlier and also prepares the upper for bonding to that sole. They initially used manual force to press the two together. And then the shoe is subjected to mechanized pressure. Inside this machine, a rubber bladder expands to force the two together for a complete seal. The shoe then gets a foam insole with an arch support. The worker laces it partially and then pairs it up with the other shoe. An inspector examines the pair for defects. It has taken about 21 minutes to make this pair of athletic shoes. And they should be able to take a real workout.